The driver of a car going 90 km per hour suddenly sees the lights of a barrier 40 meters ahead. It takes the driver 0.75 seconds to apply the brakes, and the average acceleration during braking is 10 meters per second squared. A. Determine whether the car hits the barrier. B. What is the maximum speed at which the car could be moving and not hit the barrier? Statement in a short form. Let V0 stands for the initial speed of a car, 90 kilometers per hour. Distance between the point where the driver sees the lights and a barrier S equals 40 meters. Let tau stands for reaction time, 0.75 seconds, and acceleration A equals 10 meters per second squared. A magnitude of acceleration vector. The car decelerates. Well, A. Determine whether the car hits the barrier. A. Hits or doesn't. And B. Let's find V maximum. Let's find maximal speed at which the car could be moving without hitting the barrier. So let's draw a simple sketch. The road along x-axis. Here the initial position of a car when the driver sees the lights. Then it takes 0.75 seconds to apply brakes. And at last, here is the barrier. The total displacement of a car can be divided into two parts. The total displacement, S vector, consists of two vectors, S1 vector and S2 vector. During the displacement S1, the car moves at a constant speed of 90 kilometers per hour. Then the car starts braking, decelerates. Let's first answer the question, what is the maximum speed at which the car can move without hitting the barrier? So it stops immediately in front of a barrier. B. V maximum. So we can write S1, since the car moves at a speed V maximum, during the latency time tau. This product is S1, distance S1. S2, x component of S2 vector equals final velocity x component squared minus initial velocity Vx maximum squared divided by 2 ax. A is vector of acceleration. X component is minus a. Final speed Vx final equals 0, and x component of V maximum equals V maximum. So we can write for S2, since S2 directed along x, S2 equals V max squared over 2a. S total displacement, or total distance, is 40 meters, is the sum of these two values, S1 plus S2. So we can write S1 V maximum times tau plus V maximum squared over 2a gives S the unknown is V maximum. We have a quadratic equation. Let's rearrange this equation to have 0 right side from equal sign. The first term plus the second term minus S equals 0. Let's compare it with the quadratic equation in the standard form. Ax squared plus bx plus c gives 0. And the formula for roots of this equation is x equals minus b plus minus root from b squared minus 4ac over 2a. Let's compare to these equations. 1 over 2a instead a, tau instead b, and minus s instead c. And use this formula. X equals 2a in denominator. So 2a goes before the fraction times 2 minus b minus tau plus minus square root b squared tau squared minus with this minus gives plus 4 a unit over 2a times c s. Okay, these twos divides out. Now, let's take this tau squared out of the root. To make this, let's multiply tau squared and divide tau squared the last term. It gives a tau minus. Then, look here, minus doesn't make sense because x is our maximum velocity. So we remain only plus. And here, let's write v max equals minus a tau plus a from here tau from the root 1 plus tau squared from the numerator goes out and remains 2s over a tau squared. 2s over a tau squared. And let a tau bring out of brackets. We have a tau times square root unit plus 2s over a tau squared minus 1. This is, in fact, the result of our calculation. So we can write V max equals so maximum speed is a 10 meters per second squared, tau 0.75 seconds times unit plus 2 times 40 meters over 10 meters per second squared divided by tau squared. Tau 0.75, 3/3 squared is 9/16 second squared minus 1. Units. Second and second square partly divides out. Meters divide out. Second squared divide out. So we have dimensionless root minus dimensionless unit, and after calculations we have the result in meters per second, and it gives 22 meters per second. 22 meters per second. And now let's write it in kilometers per hour. 22 times 3.6 gives us 78 kilometers per hour. So V max is 78 kilometers per hour. Answer B. And now answer A. V0, 90 kilometers per hour. Is greater than Vmax. So the car hits the barrier. Unfortunately, the problem is solved.